Hello and welcome to the Management Channel. In this session we're going to take a look at capacity planning for manufacturing. We're going to learn how to define and measure capacity, determinants of effective capacity, take a look at some capacity alternatives, learn about production constraints, constraint management, and we're going to get right into capacity planning. What is capacity? What does this mean? Capacity is the upper limit or ceiling on the load that an operating unit can handle, or the maximum production that an organization can produce within a given time frame. The throughput, or number of units a facility can hold, receive, store, or produce in a period of time, determines fixed costs, and determines if customer demand will be satisfied. The goal is to achieve a match between the long-term supply capabilities of an organization and the predicted level of long-term demand. Overcapacity results in operating costs being too high, producing more than you're capable of. It could result in overtime and various costs. Undercapacity is strained resources, too much personnel, not enough customer demand. Defining and measuring it, there are three types of capacity to be familiar with. One is design capacity. The maximum output rate or service capacity an operation, process, or facility is designed to do, or capable to produce, normally expressed as rate. Effective capacity is that which a firm expects to achieve given current operating constraints, generally lower than design capacity is. An actual output is the rate of output actually achieved. It cannot exceed effective capacity, and it's dependent upon a lot of reasons. Equipment outage, vacation time, power outage, you just don't know. Utilization is a percent of design capacity achieved. So utilization equals the actual output divided by the design capacity. So if the utilization is 75,000, but it was designed to be 80,000, you're at 93.8% capacity. Efficiency is the actual output divided by the effective capacity. So if the effective capacity is 75,000 and the actual output is reverse that. If the actual output is 75,000, but the effective capacity is 77,500, you would be at 96.8 efficiency. The actual output is the product you actually produce for sale. In our case, we say 75,000 on average. So efficiency is the efficiency actual output divided by the effective capacity, and the utilization is the actual output divided by design capacity, and they're measured in percentages. For an example, actual production of a bakery last week, 148,000 rolls. But their capacity, effective capacity, is 175,000 rolls. Design capacity is 1,200 rolls per hour. The bakery operates 7 days a week with 3 8-hour shifts. So, the design capacity is 7 days a week times 3 shifts times 7.5 hours times 1,200 rolls per hour equals 189,000 rolls. It'd be 157.5 hours times 1,200 is the rolls per week design capacity. Actual work hours are 7.5, by the way, per shift. Workers get 2 15-minute breaks and lunch is unpaid. So that's why 7.5 hours. Design capacity is 7 days times 3 shifts times 7.5 hours times 1,200 rolls per hour equals 189,000 rolls. So the utilization is 148,000, what they produced last week, divided by the design capacity of 189,000. So the utilization is 78.3%. Efficiency is 84.5%. The expected output, 175,000 times 0.845 equals to 147,875 rolls. That's capacity divided by efficiency. Managing demand. When demand exceeds capacity, you curtail the demand by raising your prices or scheduling longer lead times so that you can control the capacity. Long-term solution is to increase your ability to produce more. When capacity exceeds demand, you want to stimulate the market. Drop your price, offer a rebate or some kind of a special sale. Introduce some new product improvements or product changes. For instance, also adjusting to seasonal demands. Produce products with complementary demand patterns. In the winter, you produce snowmobiles. In the summer, you produce jet skis. Tactics for matching your capacity to demand. Number one, unfortunately, it's always this one, make staffing changes, increase or lay off. Adjusting equipment, purchasing additional machinery if needed, or selling or leasing out existing equipment, selling it if you don't need it, or leasing it out if you're not producing as much. Improve your processes to increase throughput. Redesign products to facilitate more throughput, and adding process flexibility to meet changing product preferences. You could also consider closing facilities or shutting lines or machines down. Everybody wants to have a capacity cushion. What is meant by that? It's extra capacity used to offset any demand uncertainty. So capacity cushion equals 100% minus utilization. For our example that we use, we have 100% minus 78.3. So from example, and we have 21.7% capacity cushion. The strategy is that organizations that have greater demand uncertainty typically have a bigger capacity cushion. Organizations that have standard products and services generally have a less capacity cushion because they know pretty much what their demand is. So the steps in doing so is number one, estimate future capacity requirements. Evaluate your existing capacity and facilities. Identify any gaps you might have. Take a look at what alternatives you have for meeting requirements. Conduct a financial analysis. Assess your key qualitative issues. Select the best alternative for the long term. Implement that alternative that you chose. And then monitor the results. So let's look at this one. You have two identical sandwich lines. Lines have 2 workers and 3 operations. All completed sandwiches are wrapped. So you can see the order takes 30 seconds. The bread takes 15 seconds. Filling the sandwich takes 20 seconds. Toasting it is 40 seconds. And wrapping is 37.5 seconds per sandwich. The toast workstation has the longest processing time of 40 seconds. The 2 lines each deliver a sandwich every 40 seconds, so the process time of the combined lines is 40 divided by 2, since they both produce a sandwich, equals 20 seconds. So in every 20 seconds, 1 sandwich is ready. At 37.5 seconds, wrapping and delivery has the longest processing time and is considered the bottleneck of the process. Capacity per hour is 3,600 seconds divided by 37.5 seconds per sandwich, or you should be looking at 96 sandwiches per hour. The process cycle time is 30 plus 15 plus 20 plus 40 plus 37.5, and that's where we get the 142.5 seconds from. Strategies used to offset capacity limitations and intended to achieve a closer match between supply and demand are called demand management strategies. They include pricing, promotions, discounts, and any other tactics you may have to shift demand from peak periods down to the slower periods. Should we do in-house or outsource? Once capacity requirements are determined, the organization has to decide whether to produce a good or service itself, or maybe outsource some of it. Factors to consider are the available capacity, your expertise on the topic, quality considerations, the nature of the demand, what is the cost involved, and importantly, what risks are involved. And I include, do you have the equipment and technology to be successful? While there are many reasons to outsource, some might be low volume product costing you more to produce it than what you make, a special application you are having problems with or lack expertise, for instance, in chrome plating of plastic parts. That's a science all in its own. Or making room for more profitable part production in-house and outsourcing your low-profit items to alternative suppliers. Some capacity strategies are leading by build capacity in anticipation of any future demand increases, following by building capacity when demands exceed current capacity. Which strategy is better? Tracking really is the best method, similar to the following strategy, but adds capacity in relatively small increments to keep pace with the increased demand. Economies of scale. If the output rate is less than the optimal level, increasing the output rate results in decreasing average per unit costs. Reasons. Fixed costs are spread over a large number of units. Construction costs increase at a decreasing rate as facility size increases, and processing costs decrease due to standardization. Diseconomies of scale. If the output rate is more than the optimal level, increasing the output rate results in increasing the average per unit cost due to costs such as overtime, additional utilities, and so forth. Reasons for this. Distribution costs increase due to traffic congestion and shipping from a centralized facility rather than multiple smaller facilities. Or complexity or technology increases in costs, and inflexibility can be an issue. Operation bottlenecks is something where in a sequence of operations whose capacity is lower than that of the other operations is a bottleneck or a constraint. Taking a look at this process flow chart, what do you think the two constraints are here? I'm going to give that to you for a moment to study. Pause if you need to. Taking a look at the steps, you'll see that there are two steps that take longer than the average of all the other steps. And so these two are the constraints. Doing a bottleneck analysis and theory of constraints, each work area can have its own unique capacity. Capacity analysis determines the throughput capacity of a workstation in a system. But a bottleneck is a limiting factor, or what we call a constraint. A bottleneck has the lowest effective capacity in the system. Constraints is something that limits the performance of a process or system in achieving its goals. It could be the process, could be the market, could be your resources, your material, could be financial, could be some policy or a lack of knowledge or competency. Resolving these, identify the most pressing constraint. Change the operation to achieve the maximum benefit given the constraint. Make sure other portions of the process are supportive of that constraint. Explore and evaluate ways to overcome the constraint. And repeat the process until the constraint levels are down to an acceptable level. Or said better, try to balance the process so every step beats to a consistent beat pattern, much like a metronome. 30 seconds, 29 seconds, 30 seconds, 31 seconds, 29, and so forth. Not 30, 45, 22, and 60. That's irregular. Evaluating your alternatives. They should be evaluated from varying perspectives, like economic. Is it economically feasible to make a change? How much will it cost? How soon could we have it? What will operating and maintenance costs be? What will its useful life be? Will it be compatible with the present personnel and present operations? And non-economic reasons. Public opinion. A cost volume analysis focuses on the relationship between the cost, the revenue, and the volume of output. Fixed costs are those costs that remain constant regardless of the output volume. Overhead, salaries. Variable costs vary directly with the volume of the output. So it would be quantity times variable cost per unit. Total cost would be total cost equals the fixed cost plus the variable cost. And the total revenue would be the revenue per unit. The total revenue times the quantity. Hope you found this helpful. Thank you for watching, and hope you'll take a look at some of our other topics here. Have a great day.